Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL November 2022 paper 2 past paper. Today we will be solving the question number 12 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring Classes. So without any further delay, let us start with our today's session. The question number 12, maximum mark is 22. Consider the points A 1, 2, 3, B K, negative 2, 1 and C 5, 0, 2 where K belongs to the set of real numbers. So part A says write down the vector AB and the vector AC. So I start my answer from this part. It is AB. So we will be taking this vector first. These are the coordinates of the point B and these are the coordinates of point A. So written in position vector form, it will be K minus 2 and 1 for B, and the A vector will be 1, 2, 3 can be written in column vector form, the position vector form in this way. Okay. So AB vector will be this vector minus this vector. So it is K minus 1 and minus 2 and 1 minus 3. So this is equal to K minus 1 minus 4 and minus 2. Okay. Coming to the AC vector. The position vector of the point C will be 5, 0 and 2. Okay. So it is AC is equal to 5 minus 1, 0 minus 2 and 2 minus 3. Equal to 4 minus 2 and minus 1. Okay. Fine, we have answered subpart A. Coming to subpart B. Given that the points A, B, C lie on a straight line, show that K equal to 1. Sorry, K equal to 9. The marks that it contains is 1. So, since these 3 points lie on the same straight line, maybe this point is A, this point is B, this point is C. So these lie on the same straight line. So this is the AB vector and this is the AC vector. So they lie on the same straight line. That means these two vectors are parallel to each other. So B, since points ABC C lie on the same straight line, on a straight line, therefore the vector AB should be parallel to vector AC. Okay. And because the AB vector is parallel to AC vector, therefore I can write that the AB vector is a scalar multiple of, I am having K, so let me take M. Scalar multiple of the AC vector, okay, where M belongs to the set of real numbers. Okay. So I'll be creating the AB and AC. It is AB is K minus 1, negative 4 and negative 2. This should be equal to M times 4 minus 2 and minus 1. Okay. And we have to get the value of K. We have to show that the K value is equal to 9. Therefore, first of all, let us take, I cannot take the first row because if I take the first row, it is K minus 1 will be equal to M times 4 or 4M. So in one equation, I'll be having two variables K and M. So I cannot find the value of any of them. Therefore, I am taking the second equation. It is the second row, negative 4 equal to M times negative 2. So negative 4 is equal to M times negative 2 is negative 2M. I can cancel these two minus signs. So M value is equal to 2. And now we come to the first equation, the first row. Therefore, K minus 1 is equal to M times 4. So 2 times 4, which is equal to 8. So K is equal to 9. Shown. Okay. So we have answered the subpart B and coming to subpart C. For K equal to 9, let L1 be the line passing through A, B and C. Okay, because A, B and C, they lie on the straight line. That is why the K value is equal to 9. And that line is named as L1 and I is subpart, the first subpart of the subpart C says find a vector equation of the line L1. Okay. So, what all do you need in order to write a vector equation? You need the coordinates of a point which is on the line and you need the direction vector of this line. Okay. So, the direction vector is you can take either the AB vector or the AC vector. Let us take this. So, we have the direction vector as the AC vector and we can take any point. Let me take the A point as a point which is lying on the line. So subpart C, I point is taken as 1, 2, 3 and the direction vector is equal to 4, 4 and negative 2 and negative 1. Okay. So therefore, the vector equation of the line L1 will be R equal to the position vector of the point A, 1, 2, 3 plus, I can write lambda, you can write any parameter over here, and 4, negative 2, negative 1. 4, negative 2 and negative 1. This is the direction vector. Okay. Coming to I, the second subpart of the subpart C. So line L2 has the equation x minus 1 over 2 equal to y over 3 equal to 1 minus z. This is the Cartesian equation of line L2. This is given. Show that the lines L1 and L2 are skew and it contains 10 marks. Okay, let me write the parametric equations of the line L1. Okay, so x is equal to, this is for the I part, but I'm writing it over here. X equal to 1 plus 4 lambda. Y is equal to 2 minus 2 lambda. And Z is equal to 3 minus lambda. Okay. And now I am starting my answer from this point. It is x minus 1 over 2 equal to y over 3 equal to 1 minus z. It should be in the form x minus 1 or y minus something, z minus something. So I am writing this in the form z minus 1 over minus 1. Okay. Because I need to have it in the form of x minus a over something, y minus b, z minus c, that way. Okay. So it is z minus 1 over negative 1, which I can write to be equal to mu. You can take any other variable as well. And from here, so this is the L2. From here, I can write the Cartesian, rather the parametric equations of this line L2. That will be x equal to 1 plus 2 mu. Y will be equal to 0 plus 3 mu. See, 3 times mu is 3 mu and y minus 0 is, so it is 0 plus 3 mu. And z is equal to minus 1 times mu is minus mu. So z equal to 1 minus mu. 1 minus mu. Okay. And these are the parametric equations of line L1 and these are the parametric equations of line L2. And we have to show that these lines, two lines are skew lines. So how can we prove that these two lines are skew lines? These two lines can be either parallel to each other. Are they parallel to each other? If they are parallel to each other, then their direction vectors will be one will be the scalar multiple of the other. Let us get the direction vector of this line. The direction vector will be equal to, since this is L2, I am taking D2. It is 2, 3 and negative 1. And 2, 3 and negative 1 and 4 minus 2 minus 1. One is definitely not a scalar multiple of the other. That means these two lines are not parallel. Okay. Then either they can be intersecting or they will be skew lines. So then let us check whether these two lines are intersecting lines or not. Okay. If they are intersecting lines, they will be intersecting at a point. So let us just take these two equations. You can equate the x and the y's, you can equate the x and the z's, or you can take y and the z. You have to take two equations because we are having two unknowns, the lambda and the mu, whose values we have to get. Okay, because if they are intersecting lines, there will be an intersecting point. There will be an intersecting point where the coordinates of that intersecting point, the coordinates will be common to this line, the L1, and this line L2, because that point, that intersection point will be lying on both the lines. Okay. So if there is some intersection point, if there is one intersection point, then the x coordinate from the line L1 of the intersection point will be the x coordinate of the intersection point of L2 and for the others also. Okay. So let us first of all get the lambda and mu values. I am taking the x and y. So I can take these two equations. 1 plus 4 lambda equal to, this is x, equal to 1 plus 2 mu, and 2 minus 2 lambda equal to 3 mu. Okay, and this of course I have to rewrite as, because in the calculator, in the calculator you cannot input lambda and mu, so I'm rewriting them as 1 plus 4x equal to 1 plus 2y, and 2 minus 2x equal to 3y. Okay, I'm taking lambda as x and mu as y, and I'll be using the pi-inspire calculator, and I have to go to algebra and then some system of linear equations. There are two equations. The variables are x and y, and the first equation is 1 plus 4x equal to 1 plus 2y. So 1 plus 4x equal to 1 plus 2y. Okay, and 2 minus 2x, 2 minus 2x equal to 3y. Fine, enter. X equal to 0.25 and y equal to 0.5. So x is lambda. So lambda equal to 0.25 and mu is equal to 0.5. Okay. Lambda equal to 0.25 and mu is equal to 0.5. Okay, so fine. Now I can come to this point. I'm just writing it over here. Okay. So I'm taking the z because this has not been taken so far. Or else I can use another color. Let me use another color. Okay. So 3 minus lambda. It is z will be equal to 3 minus lambda is 0.25. Which is equal to 2.75. And over here, z, it is equal to 1 minus mu. So 1 minus 0.5, which is equal to 0.5. So if they are intersecting lines, then the coordinates will be the same for both the lines. The x coordinates are the same. We have made them to be the same because we have taken those values of lambda and mu such that the x and y values match. But what about the z? We did not use the z. So we are just substituting the values of lambda and mu, and we are seeing they are not the same. This proves that they are not intersecting lines. Okay, so I'm writing over here, since the z coordinates are not the same, therefore L1 and L2 are skew. Okay, so part D. For k not equal to 9, let pi be the plane containing A, B and C, because if k is not equal to 9, that means the points A, B and C, they are not on a straight line. Maybe like this, they may be located A, B and C. So you can have a plane. You can have, in fact, this is a plane on which the points A, B, and C, they are lying. Okay. And we have to find the Cartesian equation of the plane pi. Okay. So what is the Cartesian? First of all, what is the normal equation? It is di. Normal equation of a plane, it is n times r equal to n times a. Okay. Where n is the normal vector, normal to the plane. R is the position vector of any point lying on the plane, and E is the position vector of a particular point which is on the plane whose coordinates are known. Okay. So this is the normal equation of a plane, and from here we get the Cartesian equation of a plane, which is equal to maybe like, if in case you have the normal vector as written as maybe n1, n2, and n3, and r will be the position vector of any point lying on the plane, so it will be x, y, and z. So this will be equal to n1 x plus n2 y plus n3 z equal to n dot a, the dot product or the scalar product, a, depending on which point we will be taking. We may take the point A or the point B or the point C. All three of them lie on the plane pi, so we may take any of them. Okay. So I'm keeping it as it is. This is the Cartesian equation of the plane pi, which we have to find. Okay. So for that, the first thing that we have to find, this position vector of any point is very easy to find, because we cannot take the point B because B is having this K, but we can of course take the point A or the point C. So that is fine. But the first thing that we have to get is the normal vector. And how do we get the normal vector? If we have this AB, we have the vector AB. Actually, we had found these vectors in the first subpart of this question. So we are having the vectors AB and AC. These two are non-parallel line vectors which lie on this plane pi. So we can use the vector product or the cross product, and you know the cross product is a vector. Cross product of two vectors is a vector which is perpendicular to both the vectors. So it will be a vector. Maybe this is the normal vector. It is a vector which is perpendicular to both AB and AC vectors. That means it is perpendicular to the plane pi. Okay. So we have to find the cross product of AB and AC vectors. Okay. So AB cross AC equal to, and AB is K minus 1, minus 4, and minus 2, and AC is 4, minus 2, minus 1. Okay. So this is equal to, this will be I, this will be j plus this will be k. Okay. For I, we will be excluding this column. So it is minus 4 times minus 1 is 4. Minus 2 times minus 2 is 4. Okay. Now coming to j. For j, we will be excluding this column. We always start from the top right corner, top left corner. So k minus 1 times minus 1. It is minus 1. Okay. K minus 1 times minus 1 is minus 1 times minus 1 is 1 and k times minus 1 is minus k. So it is 1 minus k and 4 times negative 2 is negative 8. So minus 4 times negative. So minus of minus 8 is plus 8. And k. So we will be excluding this column. Last one. K minus 1 times minus 2. So negative 1 times negative 2 is 2. And negative 2 times k is negative 2. So 2 minus 2k and minus 4 times minus 4. 4 times minus 4 is negative 16. Negative of negative 16 is positive 16. So this is our normal vector, which is 4 minus 4 is 0. So it is, I'm not writing I can, or else I have to write 0 I. So I'm not writing I anymore. And it is 8 plus 1 is 9. 9 minus k, I'm having a minus sign outside. So I can write k minus 9 better. Okay. K minus 9 j. And this one is 2k and 18 minus 2k. Okay. Plus 18 minus 2k. J. Oh, sorry. K rather. It is k. Fine. So k minus 9j plus 18 minus 2k. K. So what I can do is, because these are in column vector form, I can write this in column vector form. Okay. So the normal vector will be 0, k minus 9 and 18 minus 2k. Okay, we are having a variable k. Can we in some way remove this variable? Because if we have a variable, how can we give the equation of the plane pi? We need a column vector with all numbers, not with a variable. So what can we do? Let us see. Let us see. I am having, so I can write n over here. So this is 0 and k minus 9 is fine. And this one is, I want to get it in the form of k minus 9. So let us see. For this, I can take out minus 2. What happens if I take out minus 2? If I take out minus 2, it becomes k, and minus 2 times minus 9 is 18. Okay. So now I can write this as, I can take out k minus 9. Okay, because I had to. I did not have any other alternative with me, because k, I don't know the value of k. K is a number, so k minus 9 will be just a number. Okay, and the vector I can take as 0. I've taken k minus 9 outside, so this will be 1 and this will be minus 2. So this can be considered as the normal vector which has all numbers. The direction vector will be this. The direction vector is given by 0, 1 and negative 2. And what will this include? If you multiply this vector with this scalar number, because whatever is the value of k, it is a number, k minus 9 will be a number. So if you multiply a vector with a number, what changes? Its magnitude changes. The direction doesn't change. The magnitude changes. What is the length of that vector? It changes. Okay. But we are interested in the normal vector, means we are interested in the direction. Okay. So we can take this vector. This is also a normal vector. This vector is normal to the plane, as well as if you multiply this vector with some scalar number, that will also be a vector which will be normal to the plane phi. And we need a normal vector. We need a vector which is normal to the plane phi. We are not concerned about what is the magnitude of that vector. It can be a unit vector, it can be a non-unit vector. It should be normal to the plane phi. So if we multiply with the scalar k minus 9, the magnitude will only be changing. The direction will still be the same. It will be normal to the plane phi. Okay. So we are taking 0, 1 and negative 2. Okay. As the normal vector to the plane phi. So we have got the normal vector, therefore the the Cartesian equation of plane pi, sorry, is equal to n1 dot x. So n1 is 0. So 0x, 0 times x, plus n2 is 1, 1 times y, plus n3 is negative 2. So negative 2 times z equal to 0, 1 and negative 2 dot, I can take this number, this point A, 1, 2, 3. I'm taking this point. I could have taken the point C also. So this is this. Okay. And what is this equal to? So this will be equal to y minus 2z equal to 0 times 1 is 0, 1 times 2 is 2, negative 2 times 3 is negative 6. 2 minus 6 is negative 4. So the vector equation or the Cartesian equation of the plane pi is equal to y minus 2z equal to negative 4. Okay. Fine. The subpart II, the second subpart of the subpart B. Okay. Find the coordinates of the point on the plane pi which is closest to the origin. 0, comma 0, comma 0. Maybe over here there is a plane point 0, comma 0, comma 0. It is not drawn to scale, obviously. And we need to find the coordinates of the point on the plane pi, which is lying on the plane pi, which is closest to this point. And I can connect this point, the origin, with any point on the plane. The B is on the plane. I can connect O to B. I can connect O to C. But will they be closest to the origin? Definitely not. For getting the closest point, I need to drop a perpendicular. The foot of the perpendicular, wherever it will be touching the plane, that will be the point which will be closest to the origin. Okay. So let me take this point to be the point P. I'm not having any point P anywhere. So I'm taking this point as point P. Let us name this line which is connecting the points O and P as the line L3. Okay. So let us find the vector equation of the line L3. The vector equation of this line L3 will be R equal to O is the point which is lying on the line, so it is 0, 0, 0 means 0, 0, 0. This is the position vector of this point, and plus I can take T, I am taking T, and what will be the direction vector? This OP is perpendicular to the plane pi, because this perpendicular distance will be the shortest distance. It will be the closest to the origin. Okay, so OP is perpendicular to this plane pi. And we know what is the perpendicular. We have known what is the normal vector to the plane pi. It is 0, 1 and negative 2. So 0, 1 and negative 2 can be considered as the direction vector of this line L3. So this is 0, 1 and negative 2. Clear? And every point on this line L3 will be having the coordinates as x equal to 0 plus t times 0, which is 0. Y equals 0 plus t times 1, which is t. And z equals 0 plus t times negative 2, which is negative 2t. Clear? Every point lying on this line L3 will be having coordinates x as 0, y as t, and z as negative 2t. And since the point P is lying on the plane pi, therefore the point P's coordinates should be satisfying this plane's equation, the equation of the plane pi. And what are the coordinates of the point P? These are the coordinates of the point P, means these are the coordinates of every point lying on this L3. So we can consider these coordinates as the coordinates of point P also. And since P is on plane pi, therefore the coordinates of point P will be satisfying, should be satisfying the equation, this equation of the plane pi. Okay. So therefore, P is having coordinates as 0 and t and negative 2t. So therefore, since P is on plane pi, therefore in place of t, y I will be writing 2e. In place of z I will be writing negative 2t, should be equal to negative 4. Okay. So minus 2 times minus 2 is 4. T plus 4t is 5t, which is equal to negative 4. Okay. So therefore, t is having the value of negative 4 over 5. Okay. So the coordinates of the point P lying on plane phi and closest to the origin are P x equal to 0, y equal to t means negative 4 over 5 and z equal to negative 2t. So negative 2 times negative 4 is 8. So it is 8 over 5. Okay. So the point which is lying on the plane P and which is closest to the origin will be having coordinates as 0, comma negative 4 over 5, comma 8 over 5. Okay. So students, this brings us to the end of this session. We have completed answering this whole paper, the IB Math AHL November 2022 paper 2. So thank you for staying with me till the end. And I'm Nilanjana Sanyal. I'm an online IB Math ESL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. And in case you have liked my explanation, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching this video. And in case you have not subscribed to my YouTube channel till now, please do subscribe to my YouTube channel. It will be motivating me to make more math videos for you. And we meet again very soon in our next session. We'll be starting with paper 3, starting to answer paper 3. So till then, bye.